applications of exponents and log. And we'll start with the first question, which talks about population of bacteria. The population is growing at the rate of 2.3%. So it's same like your rate of interest in case of a compound interest for problem. How long will it take for it to double? Right? So initial population says P0, same like your principal in case of compound interest, 1 plus R by 100 raised to n is the number of years. In this case it's the number of minutes because the rate is given per minute, and the question asks when will this become double. So when will this be twice of P0? P0 is the initial population. So 1.023 raised to n is 2, and if I take exponent on one side becomes logarithm on the other side, and I have a log to the base of 1.023. Well, is that possible? Yes, with a calculator you will be able to calculate it. Remember, the base for an exponent can be any number as long as it's positive, so 1.023 is very much possible. The question, however, asks us to write it in a different format, right? So this is a good time for me to introduce the change of base rule for you. So log of 2 upon 1.023, if I want to change the base instead of 1.023, if I want to change the base to the Euler's number and write it as a natural log, I'm going to write the answer first and then explain why I got it this way. This is what the change of base will result in. The base has been changed to e, which is the Euler's number, and that's why I have rewritten it as ln of 2 and ln of 1.023, which means natural log, correct? And that's a function in your calculator, same like log to the base 10. You also have ln on your calculator. How did it become like this? So the change of base rule says this: if log of 16 to the base 2, I want to change this, and what is the answer for this? Log of 16 to the base 2 is 4. Okay. I'm going to change the base from 2 to 4. So I want to, and the change of base rule says log of 16 to the base 4 upon log of the old base, which was 2, to the new base. So whenever I'm changing the base, the rule says log of the numerator to the new base upon or divided by log of the old base to the new base. Is it going to give me the same answer? Let's check. What is log of 16 to the base 4, which means 4 raised to what is 16? 2. And look at the denominator. 4 raised to what is 2? What should I raise 4 to? Well, square root of 4 is 2, which means 4 should be raised to half. So the denominator is half, and 2 divided by half is 4, and LHS and RHS are matching, which means the change of base rule is correct. And therefore now if you go back to the question and see how I have changed the base, instead of 1.023, the base was to be the natural log, which was number e, and so I wrote log of 2 to the base e divided by log of the old base to e, because e was the new base, and that's my first answer. The second answer asks us simplify it to the nearest minute. Obviously you will need a calculator for this. Ln 2 is a value that you can find out on your calculator. Ln 1.023 is a value. Divide that and then round it off to the nearest minute, correct? Which means they do not want any decimal answers, so round it off. You know the rounding rules, and you'll be able to figure that out. Let's look at the next question. Next question talks about mass of a radioactive decay. Look at the difference in the two. Okay, the first question was a population increase, which means it's a growing exponent, and in a growing exponent the base must be greater than 1, and you see the base is 1.023, and therefore it is satisfying the rule. Same like our geometric progression, where ratio is greater than 1, then it's an increasing geometric progression, and base is less than 1. Look at the question, the second question. It talks about radioactive decay, which means the amount should get decreasing. So it should be an exponentially decaying thing. So our base should be less than 1. Is that true or not? Let's see. M is 4 e raised to minus 0.2 t. So the mass is 4 e raised to minus 0.2 t. Okay. I am going to rewrite this as e raised to minus 0.2 raised to t. Okay, the laws of indices, right? When indices are multiplied, I can write it in this way also. And I know negative indices can be written in the positive format by doing this. Now e is a number between 2 and 3. 2 raised to 0.2 means 2 raised to 2 by 10. So there is a number that I would get in the denominator and 1 divided by that. So 1 upon e raised to 0.2 is a number less than 1, and that is raised to 2. So obviously it's a decay. So it is correct that my base is less than 1 and therefore it is a decay. Another way to represent decay is whenever you have exponent raised to a negative number, then you automatically know that it's a decay. And what is 4? Also pay attention here. Let me rewrite and say m is 4 times e raised to minus 0.2 t. If I substitute t as 0, anything raised to 0 is 1. So I am left with m equal to 4 when t is 0. So what is the other name that I can give to 4? That means it is the initial mass. So I am starting with a radioactive substance of mass 4, could be in gram, milligram, whatever. And then it is following a decay process e raised to minus 0.2 t, where t is, let's see in what unit it is. T is given in hours, okay, and it could be anything. So the first question that is asking is what is the initial mass, when will the mass reduce to 1.5 kg, and what is the half time. Okay, let's go back and see. M is 4 e raised to 0.2 t. Have we answered part A already? What is the initial mass? Yes, all we have to do was substitute t as 0, and we did talk about it. When will it reduce to, or how long will it take to reduce it to 1.5 kg? So 1.5 is 4 times e raised to minus 0.2 t. 1.5 divided by 4 is e raised to minus 0.2 t. Minus 0.2 t, exponent on one side will become logarithms on the other side. 1.5 divided by 4, and t is minus 1.0.2 times ln of 1.5 divided by 4. Are you already worrying that time is negative? Well, don't worry, and I'll tell you why. Ln of a fraction is a negative number, and therefore negative times negative, you will get time in a positive value. How do I know that ln of a fraction must be a negative number? Let me remind you, log is the inverse operation of an exponent. So whenever I get a fraction, when do I get a fraction in case of an exponent? So 2 raised to minus 2 is 1/4. 3 raised to minus 3 is 1 by 27. 5 raised to minus 1 is 1 by 5. So whenever I have a fraction, the exponent is usually a negative number. So ln of a fraction, the opposite, right? Ln of a fraction must always give me a negative exponent value. So 1.5 divided by 4 is a fraction. So ln of 1.5 divided by 4 should be a negative number, and therefore time will not be positive. So two things we have learnt in this question. One is change of base rule. What is the change of base rule? If log of x is to the base of a, and if I want to change it to b, then I do log of x to the base b, but divided by log the old base to the new base. That's the rule. And the second thing we have learnt is log of a fraction. So log of a number to any base, where the number is less than 1. Remember, log cannot have 0 or negative inputs, okay? So it can be between 0 and 1. Then the answer is negative. when you look at the graphs of exponents and logarithms, you will again get reinforced. This idea will get reinforced for you, so it shouldn't be a problem.